Hi, I'm Antonio Creas, and this is my lane detection homework. So starting off going through my code, and then I will run the program. We have the importing of NumPy as NP, and then we import CV2 and imutals. And these are like the basic importing just so we can use some of those commands in those libraries. So starting off, we're using the grab frame. This is taken from the lecture notes. Again, this grabs the first frame of the camera as per the pipeline and lets us really use that as the image we're going to be working with. Then what we do is snip the image. This I changed a couple of things here to get the AA and BB values I like, just to make sure that region of interest that I'm going to be looking at is more concise. Then we've gone here to the mask of the image. And what this does is it blocks out everything that is not part of that it blocks out things that are outside of our region of interest here. And these values, bottom line, top line, and edge line, I made to kind of just really make sure that I'm getting that nice little trapezoidal area above the hood. Okay, then we have the thresh image command, which does grayscaling and color thresholding. This was taken pretty much straight from the lecture notes, pretty straightforward. Then we have the blur image, which does a Gaussian blur. I chose 11 by 11 because if I chose 21 by 21 blurring, later on, once we get to the Ho lines, or Huff lines, it will come up with some, it would give me some errors where part of my code wouldn't work, but the 11 by 11 gave us the best working there. And it's still blurred enough. Edge image, and this basically just comes with the candy process and returns the highlighted edges from the blurred image from above. And then we have the line image, it's the hue lines or Ho lines, I don't know how to pronounce it, of the rho and theta values from each of these. All right, and that returns it and puts that in an array. So going into my code now, we have our if name is main, just to make sure that just a nice way to organize it. But I start off with initializing some variables for the code. So we have the counter here, which is used to count up how many is used for like averaging really. We have the old, and we have the old L mid, old R mid, old L bottom, old R bottom. Those are variables that I'm using as just like showing me where like these points are, and as like just like a way of storing those when we get into like the median lines that I talk, or the average lines I talk about later. And then we have now we start off with this part here. This is actually just the first line of actual like really commands. We have the camera is equal to the first the video from the video capture. That's again pretty straightforward. These are top and bottom. What these are is those are giving me lines that I want to, when I plot these lines, I want them from the pixel 130 between and pixel 200. That's really narrowing down where I want to be like plotting these lines. So I have that 70 pixel range of length. Okay, so going in. All right, while true, this is just a loop that I'm going to cycle through. It takes the initial frame, copies it, and changes it to an edge image. Okay, so that's all shown here. All right, then we go into, I'm initializing some variables for the average lines. Here we have x1 sum, y1 sum, etc. I'll get into why I have these later and some more counters. Okay, so here lines is where we're making that matrix of all the rho and theta values. And then now these for loops here is we're going to cycle through that array to get all the other values we need. So we start off taking the rho and theta for each line, and then we convert those into two sets of Cartesian coordinates, right? So basically here what we're doing is we're taking those hue lines and we're turning them into just Cartesian lines that we can plot. And then once we have values for those, x1 values, y1 values, and x2 and y2, so two different sets, we're going to go ahead and find the slope. And so, which is actually the difference in x or the difference in y, just a little bit easier for me to understand it that way. So if the slope is negative, we add it to the right bin, all these values. And what I mean by that is we're taking these values and we just add it to the x1 sum, xy1 sum. So basically what we're doing here is we're just adding up all the lines for the right lane. We're adding up all the values for the right lane, and we're putting that into one bin that we're going to divide out and find the average of each of these values. And if the slope's positive, we're adding into the left bin. So similar thing. And so what we're going to do is we're going to find the average first and second point for each left line. That's basically going to be, us dividing that counter that we're having at the bottom here by the average values. And then we're going to find the new average slope from those average values. And then we're going to go ahead and plot that between those, the bottom and top values I talked about earlier, between that 130 and 200. And then we're also going to save that just so that way we can access that later if we need to. Okay. And then we're going to go basically do that again, but for the right side here, here's this an adjustment factor for overlaying the originally sized image. That's just so that way when I go on it takes out what I cropped out so we can add it back on. Then this is the optional trapezoid. I put that in there. That was pretty easy. And then I have here's the actual plotting the lines. So it's basically saying if if these points exist, go ahead and graph it. But if not, it's not gonna go ahead and put this on the image. And then we have a wait key here down after we've displayed the image for 25, just so we kind of have some smooth motion. You really see what's going on. All right. So I'm going to pull this up. Just ran it. So here it is. You can see it sticks pretty well. The right side is updating a lot more often than the left. Okay, so now let's go ahead and let's run this again with the other one, test video 2. I'm going to rerun the lane detection. Bring that in there. So we're looking at this. You can see the lines kind of cross. That's because you're really with the area here. It's a different area that we're showing here, and because everything's so much brighter when we're doing the blurring, it's really just finding new areas, and that there are a lot more lines as to average, and that's why you can see that the lane detection is really going on the outside of those center lines. They sometimes cross earlier on, like on turns and things like that. That's just, again, that has to do with how big these lines are that they're crossing in the area we're plotting them in. You can see like when a car comes by on the left side, it will really draw that line out because of just more bright areas. But definitely does not work as well as with the other one. But that would, I guess, changing thresholding could have to do a lot with that, or really finding a more exact and precise region of interest. So ways this algorithm could be improved would be finding ways to detail if there's a car there, and if so, being able to write that out some way of the line detection. Other things could be such as changing your region of interest to be very precisely where you think the lanes could be, or really just making sure you have really good contrast, especially on those brighter ones. Really just maybe like something that could find out the average pixel brightness of the whole image so we know it's night or day, and we can really nail that down. In terms of things I changed in the algorithm, not many. I mostly just went ahead and changed some of those numbers just so I could get a really nice region of interest in like a trapezoid that I liked. But other than that, there really wasn't much changed. Another way the system could be improved in terms of hardware would be moving the camera so that it is at the very front of the car and more aimed down. So we're just focusing on the lanes in the road, not so much the horizon. It'll take care of some of those snipping issues and block out maybe some of the cars in there. So we're really just focusing on the lanes. We get a much cleaner, crisper detection.